Assalamu alaikum. Hello everyone. We are going to start exercise 1B, uh, third part of this exercise. Question number 6. Given that equation of the line representing each of the following linear graphs in the form y equal to mx plus c. So actually this is a graph given there is a one line. Its general or standard equation is y equal to mx plus c. We need to find the gradient m and state the y-intercept c. So y equal to mx plus c. C is y-intercept and m is gradient. We need to find the gradient and c, which is y-intercept. So first of all, let me explain the direction of the line, direction of the graph here. This is line which is from left to right. Its direction is from left to right. So we see if we move from left to right, it is upward direction, positive direction. For positive direction, its gradient will be positive for upward direction. If there is a some graph, we will see from left to right direction. If it is downward, its gradient will be negative. So for this graph, we need to find m, which is gradient. So, and y-intercept. What is y-intercept? Y-intercept actually that is we can find on the y-axis. Y-intercept always we will find on the y-axis and not on the x-axis. For example, this line is intersecting the y-axis at point 0, 0. For this point, coordinate are 0, comma 0. It means x0, y0. So y is 0 here. So its y-intercept is 0. And what is gradient? Gradient equal to gradient that is equal to. So if we see that, I mean that from this point, and we will locate any prominent point on the line. Here luckily we have many prominent points. This is prominent point, this is prominent point, this one we can see clearly intersecting the on the scaled points. So we can take actually rise over run. I mean that this line start from here up to here, it reached up to here. So now there is a change in the position of the line. And what is change? Actually vertical change, vertical distance divided by horizontal. Vertical distance is also called rise, and the horizontal is run. Or gradient equal to change in rise, change in rise over change in run. So what is rise, change in rise? See the vertical distance of, for example, if you take this point, its vertical distance is 1 2 3 4 units. So it is 4. And what is 1 2 3, this is a horizontal distance, that is 4 ones are 4, so 1. So gradient equal to 1. We can take, as I told before, we can take any prominent point. For example, if we consider this one on the line, so what will be the rise? Its vertical distance and horizontal distance. Vertical distance will be 1 2 3, horizontal distance 1 2 3. So 3 by 3 is 1. Same answer will be 1. And if we take this point, so what is its vertical distance, which is 1, and horizontal, that is also 1. So in each case the gradient will be the same, 1. So we can take any prominent point and we can find its vertical distance, which is also called rise, and its horizontal distance we can find the gradient. So gradient equal to 1 and y-intercept, that is equal to y-intercept here 0 in this case, because it is intersecting on y-axis at point 0 0. So we need to take the y coordinate of this point. So let's see next part of this question. Now part B of this question, this is line given, its standard equation is y equal to mx plus c. So we need to find gradient as well as y-intercept which is c. So we need to find both. So for gradient, as I told that first you should know the positive or negative. We see this line is from left to right. If we see, it is upward direction. From left to right, if we move from left to right, its direction is upward, so its gradient will be positive. And now what is gradient? We can take for example one point, this one, as I told, we can take any point, one point this one and other, suppose last one. So if we take this one, 1 2 3 4, so rise vertical distance or vertical change, that is 4, and horizontal 1 2 3 4, 4 by 4 for any point. Even if we take this point and we see horizontal distance 1 2 3 4 5 and vertical 1 2 3 4 5, so vertical over horizontal 5 by 5, that will be 1. So every case the gradient will be 1. So gradient equal to vertical change or rise over run. So as I told, we can take any point. For example, if we take this point, from this point to like this, it will come from here like this, or from this point to here. So whatever points you like, you can take. For example, from here to here, 1 2 3, 1 2 3. So we can take any number of points, and for example we can write, for if we take this point and this point, this will be 5 by 5, and if we take this point from here to here and then from here to here, this will be 4 by 4. So for example, this is 4 by 4, that is equal to 1. And what is y-intercept? For y-intercept, we need to see the point on the y-axis. This is y-axis line. So this line is intersecting the y-axis at point. What is the point? That is x coordinate of this point is 0. So 0 and minus 1. And y-intercept, actually that is equal to y coordinate. So its y coordinate is minus 1. So y-intercept is y-intercept equal to minus 1. Now part C. So C, what is the direction? Left to right, which is downward, so its gradient will be negative. So now part C, that is equal to y equal to mx plus c, and gradient or m, that is denoted by m, gradient equal to, for example, this, if we take this one, 1 2 3 4, so y is 4, x is 2, 4 by 2, and it will be negative because direction is downward, so that will be -2. And what about the uh, y-intercept? See on the y-axis, for this point x is 0 and y coordinate 8, it is intersecting the y-axis at 0 8. So this will be the y-intercept. y-intercept y-intercept that is equal to 8. Now part D of this question, part D, same equation, standard equation, y equal to mx plus c, and now left to right is this direction, so it is downward, so its gradient will be negative. So gradient, or we can write m also, this is denoted by, gradient is denoted by m. So see here 1 2. So actually this is a unit is different, taken different, not the no exactly same, 1 2 3 4. So this will be 4 by what is this, 16. So whatever unit is mentioned on the graph, we will take that unit, 4 by 16, because this is actually, in this case 1 centimeter is not taking 1 unit, actually 1 centimeter denotes 2 units, because for 2 centimeter equal to 4, so 1 centimeter equal to 2 units. So whatever unit is mentioned on the graph, we will use that unit, not the original one. So here this is 4 over 16, 4 over 16, and direction is, because downward we will write here negative, its direction is negative, so -1 by 4 is gradient. And what is y-intercept? C is y-intercept. C will be equal to, now at what point it is intersecting the y-axis, that is 0 4. This point is 0 4, and so 4, y-intercept is 4. This is the answer. Now part E of this question, standard equation is same, y equal to mx plus c. And for this part, this is from left to right, it is upward direction, it will be positive. And for m gradient, which is gradient, m will be equal to so for this line, if we take for example this point, so from this point to, if we move from this point to here and then here, so this is actually 1 2 3 unit. So vertical is 3 unit, that is 3, and this is 1 2, from 3 up to here, and this is 2. Direction will be positive, sign is positive. So next is part F. So sorry, what is the here y-intercept? It is intersecting at point, this point is x0 y3, so y-intercept is 3, c equal to 3. And what about part F? Part F, for this line, so from left to right, it is from left to right, it is a downward direction, so its gradient will be negative. Standard equation of the line is this one, and its gradient will be negative, because we found the direction which is from left to right, it is downward, so sign is negative. And what is magnitude of gradient? So we can, this is horizontal, and from here to here this is vertical. So if we move from this point, for example we take some prominent point, not this one, we take this point, for example this point is prominent, so its x is 2, and what is y? 3 to 3. 1 2 3 4 5 6. So 2 by 6. So 2 by 6. 2 by 6 minus 1 by 3. So this is a gradient. And what about y-intercept? Y-intercept, if we see where it is intersecting the y-axis, it is intersecting y-axis at point 0 on this, because on y-axis, on any point x coordinate is 0, so its coordinate are 0 and minus 3. 0 minus 3, so minus 3 we will take the y-intercept. So c will be equal to minus 3. So this is the y-intercept. Now part G, that is this one. So what is the direction? This is from left to right, but it is a downward direction. So gradient will be, first of all, line, equation of line is, suppose this one, and its gradient will be equal to, direction is downward, so it will be negative. And what is y? For example, from point this one, this to, from point this to this one, and then up to here. So 4 by 3. So this will be, vertical distance is 4 by 3. And for y-intercept, which is c, c will be equal to, that will be on y-axis. For this point, x is 0 and y is 4. So 0, 4 coordinate of this point. So it means c y-intercept is 4. So for next part H, standard equation equal to mx plus c, and gradient, find sign of this gradient. This is left and this is right. Left to right, it is upward direction, so it will be positive. Now what is vertical distance? For example, this is up to here, 4 points. So vertical is 4. And what is horizontal? 1 2 3 4 5. So this is 4 by 5 is gradient. And what about the y-intercept? So y-intercept will be here. Its coordinate are 0 and 4. So y-intercept, that is 4 y coordinate. Yani for y-intercept we will take the y coordinate, because for every point there are two coordinates, x coordinate and y coordinate. So in y-intercept we only take the y coordinate. Next is question number 7. Question number 7 is, write down the gradient of each of the given line. There are two lines, line 1 and line 2. So line 1 is horizontal, it is parallel to x-axis. So x-axis is horizontal, it is not making any angle, or it is not inclined. This is just horizontal. For horizontal line, the gradient is always 0. So for this line, gradient 0. So any line parallel to x-axis, like line 1 is parallel to x-axis, its gradient will be 0. For line 1, gradient, line 1 gradient equal to 0. And line 2, for line 2, gradient, that will be undefined. This is vertical, parallel to y-axis, so keep on increasing up to infinite point. So this is undefined. For line 2, gradient is undefined. Now question number 6 is, on sheet of graph paper using scale of 1 centimeter to represent 1 unit on x-axis and 1 centimeter to represent 2 units on y-axis. Draw the graph of each of the following functions. So I draw two perpendicular lines. coordinate Cartesian plane system. So these two perpendicular line, this is 0 and this is 1 centimeter, represent 1 unit, 1 2 3 4 5 6 7 8 9 10, so on. Similarly, this one -1, -2, -3, -4, -5, -6, -7, -8, -9, and -10, and then -11, -12. So we can, these are non-ending lines, we can continue whatever we want until whatever we want. So now for vertical distance, 1 centimeter representing 2 units. So this will be equal to 2, this will be equal to 4, this will be equal to 6, this will be equal to 8, this will be equal to 10, then 12, then 14, so on, 16, and negative numbers are here, -2, -4, -6, -8, -10, -12, so on. So actually I draw this for question number 8. Question number 8, that is part 1. So part A is, sorry, this is part A. Equation y equal to -4x plus 8, y equal to -4x plus 8, and range is -4 to 4. So we can draw table. So this is table. So x and y, -4 to 4, we can draw only a few values, not all value. 0 to 4 and 0, -2, -4, because for drawing a line only 2 points are sufficient, but here we have 5 points that those are sufficient. So if we put 0 here at the place of x, this will be 0 and this will be 8. For 2, -2s are 8 and -8 plus 8, 0. And if we put 4, 4 4s are 16, -16 plus 8, -8. And -2, this will be plus 8 and 8, 16. Again, -4 into -4 plus 16 plus 8, 24. So we have these values, and we can draw 0 and 8. We can start from 0, 0. X is 0 and y is 8. 0, 8 is this point. This is the first point. And then 2, 0. X is 2 and 0. That is this point. And 4 -8. This is 4 and -8 is here. This is the third point. So we can draw line. We have sufficient points, and we can draw some more. -2 and 16. -2 is this one and 16 is here. 16. -2 and 16, this point is here, and -4 and 24, that is very far. So we have sufficient points, no need to draw all the points. So now if we draw line, so this is the line we draw. And similarly for part B, the equation is y equal to -4x plus 2, y equal to -4x plus 2, and again draw the table. So x and y 0 to 4 and minus 2 minus 4 and as I mentioned earlier, if you want, you can draw a longer table. You can write all values 0, 1, 2, 3, 4, minus 4. But I took only a few values which are sufficient. And if I put x0, this here it will be 2, x2 minus 8 plus 2 minus 6, and x4 minus 16 plus 2 minus 14, and minus 2 into 4 plus 8 plus 2 10, and minus 4 plus 16, and this will be 18. And now draw the points 0 2 0 2 is x is 0 and y is 2, this point. And then 2 and minus 6, 2 is this one and minus 6 is this one, and 4 minus 14, 4 on x is 4 and minus 14 is here, this one. And then minus 2 and 8, minus 2 is this one and 8 is this one. Minus 4 and 18, so minus 4 is this one, minus 4 is this one, and 18 is here is 18, this is 18. So now we drew all the points and we can join the points. So this is the line. I think for this point there is some mistake. Minus 2, it was minus 2 and 8. If I recheck, sorry, it was actually, if I put in the equation minus 2 4 is 8, this will be 10. So this will be 10 actually. This is not the correct point. That is why it is not coming on the line. That was actually point was here at this point, minus 2 and 10. So this is wrong. We will write 10. This is 10. So I drew two lines. There are further lines, and you will, if you see the other lines, that is m for every line is minus 4. So same slope is same. So it means like this question, we have two parallel lines. All other line will also be parallel. Maybe the line will come here or here like this. So all the line will be parallel. Part 2 of this question is write down another set of 4 linear functions whose graph are parallel to each other. So actually these equations are also called linear functions. So write down another set of 4. We need to write set of 4 lines whose graphs are parallel to each other. So we can write any number of, for example, part 2, whose graphs are parallel. For example, if I write y equal to 2x, for example, plus 4, and y equal to 2x minus 3, y equal to 2x plus 5, y equal to 2x minus 7, for example. So now all these lines, because its slope are same, so these lines, if we draw, you will see that lines will be parallel. So this was part 2. Now question number 9. So next is question number 9. We need to draw the Cartesian coordinate lines. These are two perpendicular lines. One is this one, other is horizontal line. So this is x-axis and this is y-axis. This is central point, intersecting point, central point, and on x-axis it is told that 1 centimeter should be equal to 2 unit. So 0, this will be 2, this will be 4, this will be 6, 8, this will be 10, 12, 14, so on. Negative numbers, -2, -4, -6, -8, -10, -12, -14, so on. And on y-axis 1 centimeter 1 unit, so this will be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is 10, and these are negative, -1, -2, -3, -4, -5, -6, -7, -8, -9 and -10. So equation is y equal to 6 minus 3x for the values of x from -3 to 3. So this is actually question number 9, and part 1 equation is y equal to 6 minus 3x. So values are from -3 to 3. So we make a table, x and y. So values should be from -3 to +3. So we take, for example, 0 here, and then 1, 2, 3, 1, 2, 3, and here -1, -2, -3. So for put x equal to 0, 6 minus 0, this will be 6. Put x equal to 1, 6 minus 3, 3. Put x equal to 2, -6, 0. Again, all values are not required. You can just put a few 2 or 3 values like this up to 2, or you can leave 1 or 2 value from here. For example, you can take 0, 1, 3, 0, 1, 2 like this. If we put 3 minus 9 plus 6 minus 3 and -1, this will be +3 and 6, 9. If we put -2 here, +6 and 6, 12. If we put -3 here, +9 and 6, 15. So now we have values. We can draw graph here. 0, 6. X is 0. This is 0 and 6 is this one. 1 point is this one. 1 and 3. X is 1 and point 3 is. So I think it is better that we just take the values, for example, which is okay, no problem, we can take that is 1 and 3. 1 is in the middle because this is a 1 centimeter equal to 2 units, so this will be in the middle. 1 is here, and 1 and 3 is here up to here like this. So this is second value, and first value was this one, and then 3 minus 3, 3x on x, 3 is this one, and -3 is this one. 3 minus 3, so this is -3. Take some other values, -1 and 9. -1 is somewhere here, and 9 is this one. This value comes here, and -2 and 12. -2 this one, and 12 is actually beyond the paper. We can just we have sufficient value for to draw a line Now we can just join the points. This, if we draw, the remaining point will also cover here. So this is one line. And what about the other line? Okay, this was only one actually line, and there was only one set of points. So this line we draw for second part, the points a0 minus 2b, and second part is point a0 and minus 2b and c 1.5, c and 1.5 lie on the graph. Find the value of a, b, c. A0 will be where will be a0? A is unknown. We need to find the value of a, b, c. So we need to find value of a, b, and c. So x is a and y is 0. Y0 is on this line, y0 on this line. So on this line, I mean that on x-axis, for every point y is 0. So this is 1 point. So we can know from this point, this is x2 and y0. Its coordinate are 2 and 0. So from 1 point we can know the value of a, that a is 2. A2, we found A2. What about minus 2b0? Minus 2 is this one, minus 2, and if we see here minus 2, it is 12, the point actually beyond the lines. So from even from here minus 2 12, the pair is minus 2 12. So it means value of b is 12. Even from the first, if we see a0, so y0, you see here y is 0, for that x is 2. From the graph we can also find the value from the graph. Next is c 1.5, x y is 1.5. Where is y 1.5? 1.5 and so y is in c and y coordinate 1.5. Y is 1.5 up to somewhere here, and if we see, it should be here on this line. This, what is x here? About 1.6, 1.5. I think this is also 1.5. So c equal to, that is equal to 1.5. And even if we want, we can put this 1.5 value here. For example, 1.5 y, 6 minus 3x, and 1.5 minus 6 equal to minus 3x. So this is minus 4.5 equal to minus 3x. So minus 4.5 over minus 3 equal to x. This cancel. 3 1s are 3, 3 5s are 15, x equal to 1.5. Now question number 10 is on a sheet of graph paper using a scale of 2 cm to represent 1 unit on x-axis and 1 cm to represent 1 unit on y-axis. Draw the graph of this function for the first line, and 2 lines are given. So you need to draw the graphs. Values from minus 2 to 2 mean 0 1 2 and 0 minus 1 2. So I think this is not different from the other questions. You can solve it easily. Next question is Question number 11. The figure shows 5 lines. One line, line 2, 3, 4, 5. Find gradient of each of the line segment. So what is the gradient of this line? So if we see left to right, this gradient will be negative. So from here to here, it means 1 by 1. Its gradient will be -1. This line is parallel to x-axis. Any line parallel to x-axis, its gradient is 0. Now for this line is from left to right, is this gradient will be positive. And what about if we take this one vertical, this one 1 by 1, its gradient will be 1. We can take any prominent point, so this point and up to here, so 1 by 1 gradient is 1. For this line, this is from left to right, is this is downward direction, positive. So what is the gradient for this line? You can take, for example, which point are prominent. So direction, I mean that this is downward. And what is the from here to the distance from here to, like here, if we draw here up to here, this is this was 2.5, and here it is also 2.5. 2.5, this is 5. So 5 over if we see from here to here, that is 2.5 to this is 2.5. So this is actually 1. This is 0.5. This is 0.5 to 2.5. So this will be horizontal distance will be from here to here, that is 2. You see, half this unit and half this unit and 1 this one, 2. So this will be 5 over 2, 2.5. Its gradient will be 2.5. And this line number 5 is vertical line parallel to y-axis. It is infinite or undefined, its gradient. So its gradient is undefined. So question number 12. So in question number 12, 6 lines are given, and in the question it is given that if gradient of line 5 and line 6 are -3 and 1 by 2. So directly gradients are given for this line and this line. Now we need to find the gradient of line 1, 2, 3, 4. See this line minus line 5. This is parallel to this line. Parallel line have equal gradient, so its gradient will be -3. And this line is parallel to this one. Its gradient will be 1 by 2. And this line, this is a vertical line parallel to y-axis. It is undefined. Its gradient is undefined. Line 1 is parallel to x-axis. For x-axis, the gradient is 0. So its gradient is 0.